Okay, so let's dive in. Imagine this. You've got a declassified government document, right,
Hmm.
from the 80s, and it's talking about training people to do well, something that sounds straight out of science fiction.
Yeah, pretty wild stuff for sure.
Exactly. So today, we're digging into exactly that.
Yeah.
A CIA report from December 86. The title is A Suggested Remote Viewing Training Procedure.
Right.
It's all about teaching people to, and I'm quoting here, accurately perceive information inaccessible through the conventional senses.
Wild, yeah.
It certainly grabs your attention. And this wasn't just some internal thought bubble either. It was a report prepared by SRI International,
Stanford Research Institute.
so under subcontract to another company, Consultants International, or CI as they call them in the document,
Okay.
authored by G. Scott Hubbard and Gary O. Langford. And it was prepared for Peter J. McNellis, who was a government's technical rep, basically overseeing things, right, the liaison. And our mission today, like always on the deep dive, is to take your source material, this pretty incredible document, and really dig out the key info, the surprising bits, and help you understand what it's all actually saying.
And it's important to note this report wasn't positioned as like the definitive scientific proof.
No, definitely not presented that way.
The document itself is pretty clear on that. It's significant, though, because it was the first full published report on remote viewing RV methodologies, specifically from CI.
Okay.
And it came out of, well, 13 years of broader parapsychology work, some formal, some informal, plus 6 years where they were just observing novices trying this stuff out.
So a lot of background.
Yeah, but they stayed up front. This isn't a rigorous scientific study. It's based on observation, introspection, informal experiments, though they do mention some concepts were undergoing more formal testing around the same time.
So the goal wasn't necessarily, RV is absolutely real, here's the proof, but more like, okay, if this phenomenon exists, how might we actually train someone to get better at it?
Exactly. They wanted to suggest procedures that could maybe evolve into a testable training method down the line.
And also capture the experience itself.
Right, and also to put together a detailed report on the subjective experience of RV, based quite a bit on the insights of an expert viewer they work closely with, Gary Langford.
Okay. And you mentioned right away, there were two key concepts that sort of jumped out.
Yeah, two core ideas seem central to their whole proposed approach. First, this idea of a perceptual window or channel, they called that targeting.
Targeting, okay.
And second, a process they called bit grabbing, capturing these little pieces of data.
Bit grabbing. Okay, this is where it starts to get really fascinating.
Hmm.
Trying to systematize something so subjective.
Right, taking something that sounds almost mystical and breaking it down.
So let's set the stage for how they thought this might actually play out. We're going to dive deep now into this proposed training process, the really strange nature of the data they talk about accessing, and ultimately what this report suggests about whether remote viewing could actually be taught, maybe even improved. Okay, let's unpack this.
So first off, how are they defining remote viewing in this specific context?
Good question.
They described it as an apparent ability. Note the word apparent.
Mm-hmm.
Careful phrasing. An apparent ability to accurately perceive information inaccessible through the conventional senses. So, getting impressions, maybe words, symbols, descriptions of events, places, people, objects, even feelings.
From somewhere else entirely.
From a target that was distant or hidden somehow. And they note, sometimes these impressions had surprising accuracy and detail.
Okay, so if you were, say, a trainee in this program, what would a typical RV session look like according to this procedure?
Well, they laid out a basic structure. You'd have three main components or roles. There's the viewer.
A person doing the viewing?
Yeah. Right, the percipient. Then the monitor, who's kind of the guide, manages the environment, provides the prompts, tracks progress.
And the target.
And the target, which could be, well, almost anything imaginable. An object, a place, an event, maybe even a concept, as long as it was designated beforehand and had some unique characteristic.
How'd they pick the target? Was it, like, random?
Often, yeah. An experimenter would select one, maybe from a preset pool, sometimes using a computer's pseudo-random number generator, PRNG they call it.
PRNG, okay.
Or maybe just grabbing a photo out of, say, National Geographic. Then the monitor gets the target, often in a sealed envelope, takes it to the RV area.
So the monitor knows, but the viewer doesn't.
Correct. The viewer then tries to access the data. And then this is crucial. After the session ends, the monitor opens the envelope and shows the actual target to the viewer.
Ah, the feedback.
Yes, the report really hammers home that this feedback process is absolutely vital for learning, for reinforcing the correct perceptions.
Makes sense. Crucial for learning. Okay, now you mentioned targeting and bit grabbing earlier. How did those concepts fit into how they saw this data emerging?
Targeting was their name for the idea that this RV data wasn't just random noise. They believed it could actually be accessed on demand.
On demand. How?
Through the proper application of a stimulus response technique. Their method used a neutral word given by the monitor.
Just a word.
Yeah, a neutral word. The idea was the stimulus would momentarily cut through the mental noise. We'll get to that, opening up a brief RV data access window.
Okay, a window. How brief?
And this is one of the really striking claims. They described that initial window, that first mental impression tied to the target, as being incredibly short, like 0.5 to 1 second long.
Half a second. To perceive something complex, that's...
Oh, wow. Astonishingly fast. Right. It's not like seeing a clear picture.
So not a sustained image at all.
No, not according to this report. They explicitly state that the correct impressions are fleeting, they're vague, indistinct, and very often non-visual initially.
That's non-visual.
These are the bits of data, the bit grabbing. They have a symbolic quality, and figuring out what they mean, interpreting them correctly, that's something they believed came with experience and training.
Okay, so you're trying to grab these tiny, fuzzy, maybe symbolic glimpses in just a split second. How on earth did they think you could even get your mind quiet enough to do that?
Right. That leads directly to their concept of data acquisition through noise reduction. The report basically argues that our normal waking mind is just full of noise.
Wise like.
Things like, your ego, worries, random memories popping up, imagination running wild, analytical thoughts trying to make sense of things.
Like static on a radio trying to tune in a faint station.
Exactly like that. A perfect analogy. So the first goal was to quiet the mind, to achieve what they called a quiet state.
Okay.
Then applying that specific stimulus word from the monitor was supposed to reduce the noise even further, just for a moment, opening that brief access window.
Did they mention techniques for getting quiet?
They do mention things sometimes associated with this, yeah. Sensory isolation chambers, trance induction like hypnosis, maybe white noise, or a visual gray field like staring at a blank screen.
Standard sort of altered state stuff.
Kind of, but here's another fascinating twist. They also warn that impressions you might get during other kinds of noise reduction efforts, especially if they're vivid visual images, often actually contribute more noise rather than being useful RV data.
Wait, hang on. So the clearer and more picture-like the impression feels, the less likely it is to be the actual remote viewing data.
That's what they claim. Totally counterintuitive, isn't it?
Completely. Usually you'd trust the clear image.
Right. But it's a critical distinction they make. They found, or believed they found, that valid RV information is almost always non-visual at first. And even when it becomes visual, it's typically indistinct, fuzzy.
Wow.
So because the correct data is so impressionistic and fleeting, they developed this method using symbols, these bits, to represent general features of targets, especially for training novices.
Learning a new symbolic language, basically.
Yeah.
What did these bits look like? Can you give examples?
Sure. The report has examples like in a figure and an appendix. Things like angular lines that might represent steep cliffs or man-made structures. Curved lines could mean a bounded area or maybe a channel like a river.
Okay.
Straight lines might suggest a boundary or maybe where land meets water. Irregular wavy lines could be rolling terrain, hills. Jagged lines, maybe mountains. Even just dots could mean light-dark contrast or a shaded area.
So the novice has this huge task. Learn to spot those super brief access moments, respond to the stimulus word, trust that the fuzzy, indistinct impression is the real data, not the clear picture.
Right.
And then quickly jot down the right symbol for that fuzzy impression. That sounds incredibly challenging.
It really does. And the report acknowledges it takes a lot of practice. They suggest maybe 25 to 30 viewing sessions before someone starts getting reliably good at telling the difference between these faint bits and their own mental noise or imagination.
Takes time.
Yeah. The idea is, over a whole session, these single-bit impressions start to combine, forming a more complex perception, first describing the target spatially, then adding details. They tend to come in clusters, apparently.
This whole thing feels very, very structured, which makes sense if you're trying to build a training method. The report actually lays out a specific 3-phase procedure, doesn't it?
It does. CI proposed this very structured approach. 3 distinct phases. Phase 1 is called access. Focus is on noise reduction and just making that initial contact.
Access, okay.
The goal is to uniquely identify the target in your mind and establish that need to describe it. So the steps. Monitor gives the stimulus word. Viewer tries to capture that very first impression, half a second to a second, remember, and then immediately takes a break, like 10 to 30 seconds.
A break right away.
Yeah, a short break. And here's where that I/O rule is crucial. If any impressions during that access moment felt vivid or distinct, you write them down, but you have to label them interpretive overlay, or I/O.
Because those are probably noise.
Because, as we said, those were considered highly likely to be noise. Yeah. Meant to be discarded.
Okay, so clear means probably wrong. Label it I/O.
Yeah.
Got it. What's phase 2 then?
Phase 2 is objectify. That's the data recording part. The goal here is to quickly write down that first, hopefully correct, vague impression using the right bit symbol you've learned.
Quick sketch or symbol?
Exactly. The viewer has to keep reminding themselves. Valid data appears vague, indistinct, and again, immediately after writing it down, take another 10, 30-second break.
Another break.
Yep. And you keep doing that, record any vivid stuff, but always, always label it I/O. That's just noise to be set aside.
Okay. Access, objectify, phase 3.
Phase 3 is qualify. This is where you start building out the description, interpreting the bits you've gathered.
Putting it together.
Right. The goal is basically to repeat the access and objectify steps, get a bit, record it, take a break, get another bit until you feel you've described the target in enough detail.
And this is where you go beyond just the symbols.
Yeah, now you start describing the target using actual attributes. The report lists a whole bunch. Texture, function, color, age, motion, shape, orientation, even things like associated emotions, time period, use, weather, lighting, terrain, cultural aspects, sounds.
Wow, a lot of potential detail.
A whole checklist, essentially. The session ends when the viewer feels the description is complete, or when the monitor finally provides the feedback by revealing the actual target.
Let's go back to that interpretive overlay, the I/O. It really sounds like the biggest obstacle they identified.
It definitely seems like it. I/O is basically any information the viewer perceives that overrides or changes the actual target data coming through.
Like static taking over the signal.
Sort of, yeah. Or maybe like your brain trying too hard to make sense of a faint signal and substituting something familiar but wrong. It's almost always described in the report as vivid, clear, often feels experiential, looks like something you recognize.
And hard to ignore, presumably.
Extremely hard, it seems. The report emphasizes that learning to deal with it, to recognize it and set it aside, takes extensive training and practice.
How much of a problem was it, really? Especially for beginners.
Get this. The report estimates that in novice sessions, something like 80 to even 100% of the session time could be spent just generating and dealing with I/O.
Almost the entire time.
Yeah. Even for advanced, experienced viewers, it was still thought to be frequent, maybe taking up around 50% of their time. The key skill, again, was recognizing it as I/O, labeling it mentally or physically,
Right.
and not letting it derail the hunt for those faint, correct bits.
Okay. The report also included an example, didn't it, to show how a session might progress from bits to a fuller picture. The anatomy of viewing.
It did, yeah. They used figures to illustrate this hypothetical progression. The idea is that a viewer, as they get better, moves from struggling just to get primary bits to being able to assemble detailed descriptions from multiple bits gathered over several access periods.
Novices focus on access, experts on detail.
Pretty much. Novices might spend ages on that initial access period, getting just a few primary bits. For experts, the access part becomes more routine, supposedly, letting them shift focus more quickly to form, function, and other details.
And they used a specific target example, Petra.
Yes, the famous ruins at Al-Khazna in Petra, Jordan. Figure 5 shows the target. The other figures, 4A through 4, illustrate a possible session flow.
So what would that look like?
Okay, so initial access might give you a bit representing a steep angled drop-off, maybe like an angular line symbol.
Right.
But then the very next access period might bring a really vivid I/O. The viewer sees water, cliffs.
Well,
Totally wrong for Petra, right? So you label that I/O.
okay, discard that. Next.
Next access might yield a texture, maybe hard surface, flat. Then perhaps some primary bits suggesting verticals. Later, more details could emerge, like man-made, stone, long flat, rises up sharply, maybe retracing or confirming earlier bits.
Building blocks.
Exactly. The final composite description would be built only from those correctly identified bits, eventually forming a picture, including the structure, the main pathway, the fact that it's ruins. This structured approach, with the breaks and the mandatory labeling of I/O, was designed to make the analysis much cleaner and more efficient than just letting someone ramble for 15 minutes like in the older methods.
Right. Avoids getting lost in the noise.
hmm
So did they actually use this procedure in a training program? What did they find? Did it work?
Yes, they did. CI started a novice RV training program in fiscal year 1986, FY86. They selected 9 people, apparently using psychological profiling, and they tested these core concepts, the targeting, the bit grabbing, and this 3-phase procedure.
And how did they feel it compared to earlier attempts at SRI?
Well, they specifically mentioned that older SRI work around 1975 often used that less structured free response method. Viewers would just describe impressions for maybe 15 minutes straight. The report points out a major drawback there. It was really difficult afterwards to sort out what might have been actual RV data versus just imagination or memory recall, and analyzing those free-flowing transcripts was apparently a huge burden. This new bit-grabbing method was explicitly aimed at being more efficient and clearer in capturing data.
More structured data collection. Makes sense. So what about the results from their training? Did they suggest people could actually learn this?
The report does cite some evidence they found encouraging. From an earlier FY84 SRI program involving 6 people with limited training, 2 of them apparently showed statistically significant evidence of RV.
Okay, 2 out of 6.
Then, in the FY86 CI program, using the new procedure, 3 of those previous novices participated again. They did 6 sessions each, about 100 viewings total across them. And the report states that all 3 of these individuals, using the new method, demonstrated statistically significant evidence of RV ability.
All 3. That sounds, well, significant.
It's presented as a key finding, yeah. They even give a specific statistical example for one person.
What was that?
They mention an 8-session series by one viewer. Independent judges scored the results. 3 of those 8 sessions were deemed statistically successful, meaning unlikely to be chance, at a probability level of 0.05.
Okay.
They then calculated the binomial probability for getting that many successes in the series, and it came out as 4.8 times 10 to the minus 4, which they described as highly significant evidence against chance.
Wow. Okay. That's specific.
They also add that 2 of the novices from the 84 program achieved significant results overall, and one of them, in some specific instances, apparently scored slightly better than their expert viewer benchmark.
Better than the expert. Interesting. So based on all that, what was the report's bottom line on teachability?
Their conclusion, based on this early work, was carefully worded but positive. They said the results suggest that the ability can be learned.
Suggests it can be learned.
Yeah. They thought the success they saw was likely due to a mix of things. Maybe some latent ability in the people they picked, their motivation levels, the amount and structure of the practice they got using this method, and what they called the technology itself.
The procedure is the technology.
Exactly. The structured procedure, the conceptual framework CI developed, but they were cautious too. They acknowledged that more rigorous experiments were definitely needed to figure out the relative importance of each factor, innate talent versus training versus motivation, and so on.
Right. It's interesting. They framed the method itself as a technology. The appendix in the report goes into more detail on other factors they thought influenced performance, right? And their conceptual models.
It does, yeah. Appendix B gets into that. It lists a bunch of factors they thought mattered. The viewer's raw or latent ability, of course, but also motivation, how often and how much they practiced, the time gap between sessions.
Feedback, too.
Instructional reinforcement, yeah. Feedback from the monitor or trainer. Also, how quickly they introduce new concepts during training, the type and difficulty of the target itself, and even the viewer's confidence level.
And they had charts or figures about these.
They did. Little conceptual graphs, like figure B3 suggests, unsurprisingly, that practice generally leads to improvement. Figures B4 and B5 hinted that more frequent sessions, like daily, seemed better than doing them infrequently.
Makes sense. Practice frequency.
Figure B6 indicated that strong positive reinforcement, good feedback, appeared to boost performance. B7 looked at introducing new ideas, suggesting you shouldn't overwhelm novices too quickly. There's an optimal rate. Key concepts mentioned were the ideograms, the bits, and combining multiple bits.
What about the targets? Did harder targets help or hurt?
Figure B8 suggested an interesting relationship. Simple targets might make it easier to perform initially, but once someone was trained, tackling complex targets could actually lead to better performance overall. Also, they thought giving stronger reinforcement for nailing high-value or difficult targets might improve performance.
Okay.
Figure B9 basically said experienced viewers get better at handling a wider range of targets effectively. And B10 had a really interesting, almost cautionary note.
Oh,
It suggested that very high viewer confidence might sometimes correlate with a drop in the quality of the RV data.
really? Why?
The speculation was maybe overconfidence led viewers to get sloppy, to forget or ignore the strict procedures like labeling I/O. They saw motivation level as being linked to both the quality of results and the confidence level.
Fascinating. So it's not just about raw talent. It's this complex interplay of training, practice, feedback, psychology.
Absolutely, which connects to the conceptual models they included too.
What do those look like?
Well, Figure B1 sketched out their idea of RV beta access. They imagined the target data somehow being accessed by the viewer's unconscious mind, maybe as a bit. Then it potentially travels through the subconscious to conscious awareness, perhaps via subliminal processes or tapping into past RV experiences.
And noise is the enemy.
Noise is the barrier at every stage, yeah. The monitor receives the conscious verbal report but also provides feedback while an analyst tries to make sense of the viewer's data stream.
And there was another model, B2.
That one was even broader. It showed how the viewer's total state could impact results. Things like their physical health, mental health, social, and family well-being.
Really? Even family life?
Apparently, yeah. And their motivational state, including basics like survival needs and economic well-being, all these things were seen as potentially interacting with the conscious, subconscious, and unconscious states, and therefore influencing the final RV results.
So they saw the whole person as the instrument, essentially.
It seems that way. The viewer's overall well-being mattered.
Okay, so pulling all this together, what were the main conclusions and recommendations coming out of this report?
Well, CI felt their training methodology, while still developing, was showing promise and did suggest trainability. They pointed to those key elements, latent ability, motivation, structured practice, and their specific conceptual framework or technology as being important parts of the equation.
So keep going.
Their recommendations were basically, if results continue to look promising, maybe expand the types of tasks given to both expert and novice viewers. But critically, the big recommendation was to conduct rigorous, formal scientific tests of CI's concepts and training methods.
To really nail down if it works and why.
Exactly. To move beyond suggestive findings based on informal observation and towards establishing effectiveness through systematic, controlled experimentation.
So even with the intriguing early results they reported, they finished by emphasizing that need for proper scientific validation.
Precisely. It wasn't presented as a closed case, more like a promising avenue needing serious investigation.
Okay, so we've really gone deep into this unique document, haven't we? Peeling back the layers on how, back in the 80s, the CIA and SRI were seriously exploring if people could be trained in remote viewing.
It's quite a journey through their thinking. We saw how they tried to break down this really elusive ability into something more concrete, capturing those fleeting, often non-visual bits of data.
And we explored their very structured training phases: access, objectify, qualify, and that really counterintuitive battle against mental noise, where the vivid stuff might actually be the wrong stuff.
Right. And we looked at those early results they presented, which led them to suggest that maybe this ability could be learned, with some novices apparently showing statistically significant success, sometimes even matching the expert.
And we learned about all those factors they believed influenced performance practice, feedback, motivation, confidence, even your overall well-being.
It really is quite remarkable when you think about it. This serious attempt to systematize something that feels so subjective, so maybe even paranormal, trying to forge it into a teachable, repeatable procedure.
It absolutely is. And this document, while it clearly acknowledges its own limitations and the absolute need for more rigorous testing, it definitely cracks open the door to thinking about whether our minds have ways of accessing information that go beyond our normal senses.
Yeah, maybe through channels we just haven't learned how to use deliberately or haven't learned how to interpret properly.
It really makes you wonder about the nature of perception itself, doesn't it? Are there other perceptual windows just waiting to be discovered or trained? What other, maybe stranger abilities might be lying dormant inside us, just needing the right conditions or the right kind of training protocol to actually emerge?
Definitely something to mull over.